Okay, so now reciprocals. So I said the inverse sine is not equal to 1 over sine. So what is 1 over sine? It actually is a different function. And you might have seen these on your calculator. So these are what's called the reciprocal trig functions. They are not the inverse trig functions. All right? So the reciprocal trig functions, you now, instead of knowing only 3 trig functions, we have now made it into 6. So when we talk about the trig functions, there's actually 6 of them. All right? So you know sine, cosine, and tangent. You're learning 3 more today. You've seen them on your calculator probably, the SEC, CSC, and COT. Okay? SEC, that's secant. Secant. So SEC is how we abbreviate that. Then we have cosecant, kind of like sine and cosine. And then we have cotangent. All right? So secant, cosecant, and cotangent. Secant is the reciprocal of cosine. Okay? So if I take 1 and I divide it by my cosine value, I get the secant of that theta. Cosecant is the reciprocal of sine. Cotangent is the reciprocal of tangent. Okay, I remember learning this and I'm like, why couldn't they have just left the C's with the C's and the S's with the S's, right? Okay, it's because it's actually a mathematical reason why. We're not going to get into it now, we will later, but everything basically has a co with it, okay? So if I have sine, its reciprocal needs, I don't have co in the name, right? So its reciprocal needs to be a cosecant, okay? Cosine, I already have a co, so the reciprocal is not going to have a co in it. It's just secant. Okay, so basically the C and the S go together. All right, that's kind of how I remember it. And then tangent's easy. It's tangent and cotangent. All right, any questions on that? There's another thing that I want to add to cotangent really quickly. So we know that tangent is equal to sine over cosine. So then if cotangent is the reciprocal of tangent, then another way we could write cotangent is cosine over sine. All right, so if tangent, when I talk about like the slope of the like change in y over change in x, cotangent's the reciprocal. So it's not the opposites of reciprocals, it's not like perpendicular, but it's the reciprocal. It's going to be the x, it's like the run over the rise, basically. Okay. All right, so let's look at example 2 and evaluate each reciprocal trig function at pi over 6. So let's start with secant of pi over 6. So what I would start off doing is say I want 1 over the reciprocal of secant is cosine. Okay, and so then cosine of pi over 6, that was your last problem set, right? So what's the cosine of pi over 6? Root 3 over 2. Okay, so I need the reciprocal of root 3 over 2. The 1 over means I'm just going to take the reciprocal. So then I'm going to flip it and get 2 over root 3. But we want to keep it rationalized. So this is 2 root 3 over 3. You may sometimes see it unrationalized. Will I count off if it's unrationalized? No, unless I tell you specifically to rationalize. But you need to be at least familiar with both, okay, forms. All right? Okay, so is that okay? So the secant of pi over 6 is 2 root 3 over 3. Yes, sir?
So without taking the reciprocal of that, since you would multiply the 2 up, move it, it would be 2 square root 3 without being reciprocal, right? Because if there's a fraction on the bottom, then you multiply the denominator up to the numerator. And then
1 over a fraction, you just take the reciprocal. That means take the reciprocal.
So if there's another number on top, then you would have to.
Correct. Yeah. I see what you're asking. Okay, so let's try cosine of pi over 6. So cosine of pi over 6. Sorry, not cosine. Cosecant, my bad. Cosecant of pi over 6. What's the reciprocal of cosecant? Yeah, cosecant is defined as 1 over sine. So what's the sine of pi over 6? 1/2. So then the reciprocal of 1/2 is 2. Now, I'm writing all of this out. I typically, when I'm doing these problems, I typically don't write all of this out like the 1 over. What I do in my head is I say, okay, I want the cosecant of pi over 6. So I think in my head, okay, that means I want the reciprocal, I want the sine of pi over 6. So in my head, I should say, okay, sine of pi over 6 is 1/2, reciprocal, 2. That's kind of what I do in my head. You can write out as much work as you need to, okay, but that's what I do in my head. All right, so let's do one more. Let's do the cotangent of pi over 6. So that reciprocal is 1 over tangent. And what's the tangent at pi over 6? Root 3 over 3. Remember, that's kind of the less steep one. So that's the reciprocal 3 over root 3. Now, do you remember that tangent of pi over 6 when we first calculated it? Let me just go off to the side real quick and show you this. When we first calculated tangent of pi over 6, we did sine of pi over 6 over the cosine of pi over 6, right? And if you ever forget what tangent of pi over 6 is, you can still do that, correct? Everybody with me?
Yeah.
So what is the sine of pi over 6? We just had it. 1/2 over cosine of pi over 6? Root 3 over 2. So when we did that initially, we said that's 1/2 times 2 over root 3, and we got 1 over root 3, right? Then we rationalized it to get root 3 over 3. Okay, so it's kind of nice to be familiar with the unrationalized version and the rationalized version. So the tangent of pi over 6, you might have memorized now as root 3 over 3, but that's the same thing as 1 over root 3. The reason I went back through this is because this one's a lot easier to take the reciprocal of, isn't it? Because 1 over root 3, the reciprocal of that, so cotangent of pi over 6, is just root 3. Okay? Now, you could have also done this, but then you're rationalizing again. So it's just a lot of rationalizing. All right, so if I rationalize what I did up here, then you get 3 root 3 over 3, which ends up getting root 3. Okay? What I take away from that is knowing, remember I said tangent, think about it as the slope. So then cotangent is like the reciprocal slope. So you know how tangent of pi over 3 is root 3? And tangent of pi over 6 is root 3 over 3. Y'all with me? Do I need to draw that? Let me just draw this just to make sure we're all good. Okay, so at theta, tangent of pi over 3 is root 3 over 3, right? Tangent at pi over 6 is, oh my goodness, root 3. My bad. I'm sorry, I'm making lots of mistakes. Cotangent is just simply the reciprocal of those, and so it just flips. Okay, so cotangent of pi over 3 is root 3 over 3. Cotangent of pi over 6 is root 3. They just flip-flop. Okay? They're just reciprocals of each other. Does that make sense? Because root 3 and root 3 over 3 are just reciprocals already. So cotangent is just, you just flip them. Does that make sense? Okay. If you can't remember that, then you can just have to calculate it every time. Sine over cosine. All right, so let's try our next example. I'm going to do the first one with you, and then I'm going to let you try the next ones on your own. So cosecant of 2 pi over 3. So another way to do this problem, instead of saying 1 over sine, what I do is just off to the side, I say, well, let's do it off to the side. Sine, which is the reciprocal of cosecant, correct? Okay, I first calculate what's sine of 2 pi over 3. 2 pi over 3, what quadrant is that in? Second quadrant, and I'm looking for the y value at 2 pi over 3. Is that positive or negative? Positive. And what's that y value? Root 3 over 2. Okay, so that's sine of 2 pi over 3. So then cosecant is the reciprocal. Yeah, 1 over that, or just flip it, right? It's just the reciprocal. So then I go back to my work, and I just flip it. 2 over root 3. You could leave it like that, or it's just good practice to go ahead and rationalize. Questions on that? So, before you get started on the rest, remember all students take calculus? That has to do with sine, cosine, and tangents. The reciprocal functions just do whatever their reciprocals do, right? So if sine is positive, then its reciprocal will also be positive. If sine is negative, its reciprocal is negative. Does that make sense? Okay, so now I want you to take about 3 or 4 minutes. I want you to do B through F on your own. Let's do it individually by yourself for about a minute. Don't just look at your unit circle. I know that's easy to want to do. Try it on your own first so that they can see the answers as well. All right, so now example 4. Okay, so now what we're going to do is combine what we learned at the beginning with the inverse trig and our new functions. So we're going to be looking at the inverses of these functions here. Yes, okay? All right, so we're kind of doing a lot of brain power here because you've just learned these new values. Okay, it's really not that bad though because I don't have any of these memorized. Okay, I'm not asking you to memorize more values. So the way that I would approach this problem A, all you have to do is take the reciprocal of both sides. So what's the reciprocal of cosecant? Okay, let me ask you that again. Cosecant is 1 over sine.
So sine.
What is the reciprocal of cosecant?
Sine.
Just sine. Right, 1 over cosecant. That's right, 1 over cosecant, which is sine. Okay, all right. So the reciprocal of cosecant is sine. So what I'm going to do is I'm going to write a new equation when I take the reciprocal of both sides. So the reciprocal of cosecant is sine. And then I'm going to take the reciprocal of the other side. So the reciprocal of the other side would be negative 1 over root 2, which is the same thing as negative root 2 over 2, correct? Yes? Okay, so I take the reciprocal of both sides. Now I solve that equation. It's the same answers. So you don't have to memorize these values to do inverse with the reciprocal functions. You just simply take the reciprocal of both sides and solve that. So now at what theta from 0 to 2 pi is sine, the y coordinate, equal to negative root 2 over 2? Quadrant 3 and 4. Somebody said it. 5 pi over 4 and 7 pi over 4. Good?
Yes.
Yes. Yeah. Okay, let's do B. So secant, what is the reciprocal function of secant? Cosine. So I'm going to take the reciprocal of that and equal the reciprocal of the other side. Now, instead of taking the reciprocal of that rationalized answer, we did this kind of last class a little bit. I'm going to unrationalize that answer. See how I'm unrationalizing that? And remember I said, we said 2 over root 3 is the same as 2 root 3 over 3. That's why it's good to be familiar with both. So now when I take the reciprocal, we end up with negative root 3 over 2. Is that okay? So now, when is cosine theta equal to negative root 3 over 2? 5 pi over 6, good. And when else is cosine, the x-coordinate, negative?
The third quadrant.
Third quadrant? That's the fourth quadrant. 7 pi over 6. Good. Questions? Lastly, cotangent theta is undefined. So this is where it's helpful to think of cotangent as not sine over cosine, but cosine over sine. Right? The reciprocal of tangent. So if you think of cotangent as cosine over sine, well then cotangent will be undefined when what? When sine theta equals 0. Right. So when is sine, the y value, equal to 0? On what axis? The x-axis. And what thetas represent the x-axis? 0 and pi. Correct. Okay. So on the x-axis, what slope is that? What slope is the x-axis? 0. So the tangent at those values will be 0, but cotangent is the reciprocal of that. So cotangent will be undefined there. What would cotangent be on the y-axis?
0.
0. Correct. Okay. All right.